Welcome everyone, I'm Adam. In this problem, for our given vectors u with components 4, -3, and 1, and v with the components 2, 5, and 3, we're going to find a unit vector that's orthogonal to both u and v. So to start off with, starting with what we know that if we look at a cross product, say u cross v, that gives us a vector that's orthogonal to both u and v. Okay? So we can at least find a vector that's orthogonal to u and v. And then finding a unit vector, well, we know that we can make a unit vector out of any vector by simply taking the vector and then dividing through by its magnitude or multiplying by 1 over its magnitude. So the game plan is we'll find the orthogonal vector, u cross v, and then unitize it by dividing by its magnitude. So let's start there. So we're going to find our u cross v, okay, the cross product between u and v, which using our determinant form, we'll set up our 3 by 3 matrix where our top row is I, j, and k. And then the next row is our components of u, which we have as 4, -3, and 1. And last row components of v, which are 2, 5, and 3. And so that's equal to finding the 2 by 2 determinant times I, where we cover up our I column and take the components or entries -3 and 1, and then 5 and 3, minus our determinant covering up our j column, 4 and 1, and 2 and 3, times j plus our determinant covering up our k column, 4, -3, and 2 and 5. And that's times k. Okay, so taking the determinant of a 2 by 2 matrix, right, we're going to multiply down our diagonals. So -3 times 3 gives us -9, and subtracting the other product across the other diagonal, 5 times 1. So -9 minus 5 gives us -14. So we'll find the determinants first and then put everything together. So the first determinant, -14. Our second determinant, 4 times 3 is 12, minus 2 gives us 10. And lastly, 4 times 5 is 20, minus 2 times -3, minus a -6, gives us a positive 26. So putting it together, we're going to have -14i minus 10j and plus 26k. And that's the cross product between u and v. So that's the vector that's orthogonal to u and v. Now what we want to do again is find a unit vector. Actually, separate this. So we want to find a unit vector. Well, again, we can find a unit vector by taking a vector, namely we're looking at our u cross v, and then dividing by its magnitude. So we're going to divide u cross v with the magnitude of u cross v. Okay. So here, let's start with the bottom, the magnitude. So the magnitude is just the square root of the sum of squares of the components. So it's the square root of the sum of squares of our components, -14 squared plus 10 squared plus 26 squared. Change this slightly. Middle component should be thought of as -10 squared. And then the vector u cross v on top, we'll write that in component form, -14, -10, and 26. Okay, so we just have a little bit of simplification to do. All right, so let's take a look at the bottom part here. So, and I'm going to bring out our calculator for this. So -14 squared plus 10 squared plus 26 squared gives us the square root of 972, and that's still with our vector u cross v on top. Okay, so from what we have, we can divide each component by the square root of 972, but we'll try and simplify it a little bit first. So if we take a look at this, right, and note that 972 if we divide that by 3, we notice we get 324 times 3, where 324 is 18 squared times 3. So we can bring out the perfect square of 18. So this is going to be equal to, let's write it as 1 over, so we'll have 18 times square root of 3 times the vector negative 14, negative 10, right, and 26. So multiplying each, we have negative 14 divided by 18 times the square root of 3, negative 10 divided by 18 times the square root of 3, and 26 divided by 18 divided by 18 times the square root of 3. And the last thing we can do is just simplify a little bit. Noticing 2 will cancel in both our numerator and denominator, 2 going in here 7 times, and 2 going in here 9, 2 going in here 5 times, and into 18 and 9, and 2 going in here 13 times, and 2 into 18, 9. So in the end, the vector with, say, negative 7 over 9 times the square root of 3, negative 5 over 9 times the square root of 3, and 13 over 9 times the square root of 3. So there is our unit vector orthogonal to u and v. Thank you very much.